Yes, indeed. Hi, Sam. Can you hear me?
Yeah.
Yeah, great. Okay, well, thank you so much for the invitation, and that was a really nice introduction. I also would echo Talia's congratulations on all your efforts for putting this together. This is a talk about scientific fraud, scientific misconduct. We thought we'd start the conference with a bang. I guess this is some of the most outrageous stuff that scientists can do. And I know we're all feeling slightly unproductive during the pandemic. So I thought I'd start off with one of the more prolific people that we have in the world of scientific fraud, someone who's really done a huge amount of work in terms of writing fraudulent and dangerous and awful scientific papers. And it is this chap here who is, his name's Yoshitaka Fuji. He is the world's most prolific scientific fraudster as measured by retractions. And I should say that we know about as well. I mean, there are. It's possible that there are others. And when I think of scientific fraud, what I think about is this guy, and I think about all his friends at the top of the Retraction Watch leaderboard. These are the top 10 most retracted scientists. So these are people who have fabricated or falsified data or plagiarized papers, and you can see there that there are enormous numbers of papers for each of them have been retracted. My own subject, psychology, gets a little mention there in number 5, Diederik Stapel, who Sam mentioned in his talk earlier on. And you can see that Fuji is well ahead of everyone in terms of the number of retractions. But and this changes quite a lot. You can see the link there. It's always worth checking in every so often to see just how bad it can get in terms of retraction. Now, articles aren't always retracted because of fraud. They're sometimes retracted for innocent reasons. I don't think there are any innocent reasons in this top 10. I think these are all instances of scientific misconduct. But of course, when you're focusing on the very top 10, that might be somewhat misleading. You might want to ask, how often does this actually happen? How often do scientists make up their data or falsify their data just in the everyday scientific kind of population? So in terms of defining as fabricating or falsifying your data, this is how many scientists say when you just ask them, have you ever done this? Have you ever committed fraud? This is how many scientists say that they have. So have you ever done it? 1.97% of scientists say that they have. Now, that's a terrifying number. I think that's kind of the sort of number that would keep you up at night, although it seems quite low. 2% of scientists making up their data is I think rather scary. When, however, you ask them if they think that their colleagues have ever committed scientific fraud, what you find is that 14% of them say that that's the case, and that is a really hair-raising number. It's from a meta-analysis of surveys of this research that was done in 2009. So again, slightly out of date. Someone needs to probably update this at some point soon. But that's the best numbers we have of how many scientists fabricate or falsify their data. So what I thought I would do here is talk about how these people get caught. So the things that have happened that have busted scientific frauds. Now, the disclaimer here is that these are just some of these people have not admitted to fraud. Some of these people have not been fully investigated by the universities. So I'm just saying that these are alleged scientific frauds, and so we'll just change that slightly. So it's how alleged scientific frauds get caught. Please don't sue me. And here are it keeps jumping on. So here are some of the main reasons that alleged scientific frauds get caught, or people committing scientific misconduct get caught out. One of them is that they make absurd and unrealistic claims. One of them is that they have data that turns out to be impossible or extremely improbable. Some of them have their fraud hidden in plain sight. And some of them, it's the sheer audacity of the fraud, the sheer high profile of the fraud that they commit that gets them caught. So the first one is one that's close to home. This is something which has been investigated by my own university, King's College London, very recently. This is the story of Hans Eysenck and Ronald Grossarth-Matejcek. Now, Hans Eysenck was, in the 90s, the most, or I think across the whole 20th century, he was the one of the very most cited psychologists. Certainly in the 90s, he was the most cited living psychologist. I think only Freud and Piaget were more cited than Hans Eysenck was. So he did all sorts of work on, well, a huge range of things, but the thing we're going to be focusing on here is personality. He started in the 1980s working with Ronald Grossarth-Matejcek, who's a psychotherapist, on a range of different papers that claimed that you could predict whether someone was going to die of a fatal disease like heart disease or cancer from their personality. And they developed personality questionnaires that could apparently differentiate the different types of people. So the heart disease prone personality, the cancer prone personality, the healthy personality, and so on. And most of you will be familiar, I'm sure, with personality questionnaires, but just to point out, sometimes if you have a kind of yes/no question in a personality questionnaire, it often looks something like this. It looks like, can you get a party going? And that would be testing whether someone is extroverted or introverted. That would be one way of doing that. You'd ask them lots of questions along those kind of lines. Or do you enjoy sunbathing? There's another kind of question that you might ask in a personality questionnaire. The personality questionnaires that were asked on the questionnaire by Eysenck and Grossarth-Matejcek were not like this. Here is an example item of a personality questionnaire, from their personality questionnaire. So this is one of the questions, and this is a yes/no response. You have to give a yes/no response to the following question. Do you change your behaviour according to consequences of previous behaviour, i.e. do you repeat ways of acting which have in the past led to positive results such as contentment, well-being, self-reliance, etc., and to stop acting in ways which lead to negative consequences, i.e. to feelings of anxiety, hopelessness, depression, excitement, annoyance, etc. In other words, have you learned to give up ways of acting which have negative consequences and to rely more and more on ways of acting which have positive consequences? So if you could just answer yes or no to that one. It's a shame we don't have the survey set up for that at the moment, but obviously everyone immediately knows whether they have a yes or no answer to that one. Obviously, what I'm trying to point out is that it would seem somewhat unlikely if this question was specific enough to make a good prediction of whether someone was going to die of a particular disease, right? And yet, this and questions like it were some of the most impressive predictions of people's mortality risk of any psychological variable. So there are studies, longitudinal studies that were done, apparently involving thousands of participants. 38.5% of the people who were deemed cancer prone by these kind of questions died of cancer, compared with only 0.3% of people with the healthy personality. So that's a risk of 120 times for the people who had answered in the way that Eysenck and Grossarth-Matejcek claimed was the cancer prone response. Compared with healthy subjects, people with the heart disease prone personality were 27 times more likely to die of heart disease. And then they did a psychotherapy trial. 32% of the control subjects who didn't get a special psychotherapy from Grossarth-Matejcek died of cancer, and none of the people who did get the psychotherapy died in the next 13 years. And as Anthony Pelosi, who's a critic of this research, has said, these results are unheard of in the entire history of medical science. So something is going very wrong here. Either there's been an enormous mistake, or perhaps scientific fraud has been committed, or some other explanation that I can't think of. So this happened in the 80s and 90s. All these collaborative papers were published. There was a large amount of critique and debate in the British Medical Journal in 1991, 1992, and then basically nothing happened. The articles were just left in the journals that they were published in, kind of under a pall of suspicion. They didn't get that many citations because the results were completely absurd and people thought they were rather ridiculous. But just in the last year, King's College London has done an investigation and has found that these papers are unsafe. So it's and recommended to the journals that they were retracted. And actually, just as of February, they started getting retracted. So 13 were retracted, 61 papers got an expression of concern, and it could be a very, very many papers. And actually, I think could end up, and Growth Mathematics Check could end up on that top 10 retraction watch list that I showed you, if all the papers end up being retracted. And I think the interesting thing that this brings up is it's hard to tell sometimes when something is fraud necessarily, right? It's not that there's some easy test that you can do. The results look completely ridiculous, but of course, ridiculous results are also consistent with people just being extraordinarily sloppy in the way that they put together their research. So one other example from the kind of history of psychology is Sir Cyril Burt, who was widely accused of making up results on the heritability of IQ tests in his twin data, and very famously, fraudulent numbers. These were heritability numbers that they were identical to the third decimal place, even after he kept adding more twins into his study. There's a decent explanation that was actually just a muddle. It was just sloppiness that explained those particular numbers. Although there are other numbers in other bits of Cyril Burt's work that are much more likely to be actually fraudulent. And in fact, there were some actions that he took, some things that he did, that also indicate a rather kind of devious personality. So one of his students wrote that Burt showed him a paper he had written under our joint names, and I thought it was very good. I was rather surprised when it finally appeared in the British Journal of Educational Psychology, and that, by the way, is a journal that Burt was the editor of, in 1939, with only my name at the top and with many changes in the text praising Cyril Burt. Now, I don't think that sounds like someone who has a great deal of scientific integrity. And the interesting thing here is that the student, Burt's student, who wrote that quote and who wrote that paper with him, was Hans Eysenck, and I think that just goes to show something. The next thing is that and we've already talked about suspicious numbers, but sometimes the raw data themselves can be very suspicious too. So this is a researcher, a kind of rising star in the world of spider biology. So he studied social spiders and the relation between the size of a social group spiders were in and their personalities in many ways. So it relates back to Eysenck in some ways because he's looking at personality. And he, interestingly, for what we're talking about, open science and so on, he actually posted all his data online. He worked with many different collaborators, so he sent data sets from spiders that he had observed out to collaborators at lots of different universities. And because the data were posted online alongside the papers, people were able to notice anomalies in those data. And in fact, once his co-authors looked into those anomalies, which they hadn't noticed before they published the papers, they confirmed that there were very many problems in his data set. So Jonathan Pruitt has now 7 retractions, I think, and there may even be more than that, but that's the last number that I could find. He denies that this is fraudulent. He says that there were maybe mistakes and so on, but he got himself into really deep trouble. And I think this is just another a really interesting example because he was following the open science guidelines, right? He was putting his data online, and I think if he was making the data up, if they were fraudulent, then it really takes a really brass neck to post fraudulent data sets online for the whole world to see. So there's an article in Nature you can read about that from earlier in the year. His co-authors started noticing all these repeated numbers in his data. These are measures of spider movements which were taken to the millisecond or even fractions of a millisecond, and yet for many of the different spiders, these different individual spiders, these measures were exactly the same to the second decimal point. And in fact, there were repeated elements across lots of different parts of the data. So again, entirely different spiders with rows of, and columns of identical data. Some researchers have found in one of his Excel sheets a formula that was used to possibly, if he was being fraudulent, which if he was being fraudulent, it looked like that formula was being used to alter the numbers in another row of the spreadsheet, and that was just left in and put on online and shared. That's not one of the spiders that he studied. That's one of those spiders that is pretending to be an ant. I thought it would be appropriate because it's a spider and it's deceiving people, whatever. And so those data were just sitting there. They were just hiding in plain sight. They were waiting for anyone to come along and discuss them. And can you imagine finding that someone that you've worked with, who you've published several papers with, who you've maybe you've gone to conferences and presented that research, and then you find that person has been deceiving you the whole time, as you have to lose all your trust in one of your co-authors. It's a terrifying thing, and it could happen to any of us. It's happened to very many people, and they very rarely suspect it. So here's another example of how data can be fabricated or altered, falsified. This is a set of lanes of a Western blot. They've been kind of rearranged in this Nature article, but they are from a paper that was published in PLOS One. And so you can see here all the different lanes, and if you just take a quick look at this, they seem like they're perfectly normal blurs from a Western blot. They're all kind of irregular sizes and shapes, and maybe these show important aspects of the experiment, the particular proteins. However, it turns out that many of these lanes, and these are supposed to all be different, are identical, and they have been photoshopped in such a way. Some of them have been stretched out a bit, compressed down. You can see the green one here is a shorter version of the green one at the bottom, and another one here. So this is a very, very common way that scientists commit fraud in articles, is that they have it sitting there in the figures of their articles. They're on the PDF pages. They're not hidden away in a supplement or anything. They're right there, staring you right in the face. But it just takes the right sort of person to be able to notice that these have been photoshopped, that these have been falsified. And the right sort of person is Elizabeth Vick, who is I think the only person who's pictured in this talk who is not a scientific fraudster, but is in fact a hero, and is in fact someone who's busting scientific fraud on a regular basis. And she and her colleagues visually checked over 20,000 papers from 40 journals, and found that 3.8% had problematic images. So like this one here, had images that looked like it had some degree of duplication or fabrication in there. And you can see that actually that 3.8% number is actually in more recent years, it's actually somewhat higher than that. So it seems to be getting worse in terms of the date of the journal. Now that could be because software makes it somewhat easier now for people to manipulate images in scientific papers, but it's not clear, obviously, what the cause of all this stuff is. And so it's very interesting because this leads us on quite nicely to our final reason, which is really audacious frauds. Which is, here's an example that, again, Elizabeth Vick has posted. She posted this online on PubPeer, which is the website you can use to kind of raise questions about worrying, dodgy-looking scientific papers, whether it's the data or the pictures or something else about them. And you can see here that these are cross sections of, it's the little organs inside the ear that are to do with kind of balance and rotation and so on from lots of different species. And you can see that these cross sections are, I mean, it really astonishes me that someone could notice that there are kind of repeated elements in these pictures, but there are. And this was a paper published in the Journal of Neurophysiology in 2005, which made up part of someone's PhD thesis. And you can see that there are repeated elements in these figures. I mean, it's, as I say, astonishing. Someone would notice, but what an odd thing to do to fabricate images like this, if indeed that's what has happened. But the reason I bring this up is that the person who was the lead author of this paper in the Journal of Neurophysiology is Sapan Desai, who you may recognize his name because he's been in the news in the last few days, because he was the co-author on 2 papers on hydroxychloroquine. Sam mentioned this in his introductory talk. Hydroxychloroquine, these were observational trials where they showed that hydroxychloroquine, not only was it ineffective in preventing death from COVID-19, but it was actually dangerous. It actually had side effects. It caused some side effects that actually caused a higher degree of death. So that Lancet paper, which is the top one there, actually caused the World Health Organization to suspend several of its trials into whether hydroxychloroquine worked. Now, this was so Sapan Desai is the head of a small research company called Surgisphere, and they apparently had access to these large data sets of patient data from lots of different countries, and they shared them with some researchers. So the other researchers from the Brigham and Women's Hospital, which is part of Harvard University. So some of the top researchers in the world. These are the top 2 medical journals in the world, the Lancet and the New England Journal of Medicine. And of course, you know where this is going. In the past week, or maybe just over a week, both of these articles have been retracted because people noticed problems with the data, issues with Surgisphere itself, and Desai would not share the raw data with the co-authors that had published the studies with him. So he gave them data which it seemed very odd that he would have access to it. Surgisphere is a tiny company, and yet they had thousands and thousands of patients' data with no kind of paper trail as to where that data came from. And also there were some anomalies in the data. So for instance, they reported more deaths due to COVID in their data set than had been recorded by the government in Australia, for instance. So I think they had 7 or 8 more deaths in their data set than actually existed in reality. Something had gone very wrong. Could it be that this is fraudulent? It's impossible to say at the moment, and we need a kind of proper investigation into it, and people are investigating. Part of the investigation is why the dodgy figure from Desai's PhD thesis and his paper was discovered, but we still don't know exactly what happened there in terms of the the provenance of these data. But imagine what an absolute disastrous situation this is. Not only did the WHO halt their trials, and it's actually caused a material change in the way that they're looking at the data, but also it hands ammunition to people who were supporting the use of hydroxychloroquine, which is unproven for COVID-19 at the moment. There's no evidence either way, really. It hands ammunition to those people to say, look, there's a concerted effort to try and do down hydroxychloroquine and say it's bad. And you know what? Having looked at these papers, it's impossible to say that that's not the case. So there's a case where scientific misconduct, and I would say that it is misconduct to not share your data with your co-authors, and it may even be bordering on misconduct to not look at the data. You may have noticed they had to ask him for the data after they had published the paper. What a strange situation to be in, to publish a hugely important analysis of data and not having looked at any of those data yourself. So I think what we can conclude from all this is here's some tips on how to commit scientific fraud and avoid being caught. The first thing is that keep your claims fairly circumspect. There's no point in making large, absurd claims that you can tell whether a person is going to die of cancer to some extremely high probability, or save them from getting cancer just using your psychotherapy course and your personality questionnaire. Don't make it too obvious in the data set that you've fabricated it. Real data sets look quite messy a lot of the time, and the reason that so many frauds get caught when the data are shared is that it's very obvious that the data are too maybe they just look a little bit too pristine to be real. Hiding fraud in plain sight is a terrible idea as well, especially when there are people like Elizabeth Vick around who might catch your repeated element in your data set. Sorry, in your image, I should say. And committing fraud for a hot button issue, especially like COVID-19 is right now, or putting it in a high impact journal like the New England Journal of Medicine or the Lancet, seems like quite a bad idea as well, because you get all the extra scrutiny. A lot of the most famous fraud cases are from articles published in Nature, Science, places like that, where the world is watching, the world is looking at these claims, and giving them the scrutiny that they deserve. A really scary thought obviously I'm being slightly tongue-in-cheek in saying that this is how to commit fraud and not get caught, but a scary thought is that there are almost undoubtedly lots of fraudsters out there who have followed the rules on this slide and are flying under the radar, may never get caught, have published articles in journals which look realistic enough, make claims that are interesting enough to get published, but not too exciting or flamboyant, and just are sitting there in our scientific literature, polluting our literature, and we will never find out. And that's another thought to keep you up at night. So the question is, I mean, we're going to be seeing lots of detail later today as to the reasons that scientific problems arise. But one set of reasons why fraud in particular keeps happening. I mean, James Heathers, the meta scientist and neurophysiologist, had an article in The Guardian last week talking about how peer reviewers aren't expected to pick up on fraud. It's not the case that peer reviewers are told to go into the individual data themselves and find, oh, that those two cells look identical, like that spider data set I showed you. That's not expected, and in fact it's not possible in a lot of cases because scientists don't share their data with each other while undergoing peer review. So the peer review process, which we view as this kind of bulwark against incorrect claims and so on, may not be in practice. When you commit fraud, you have full control over your results. You can make your results precisely the sort of thing that you think the reviewers and the editors at the journal want. So you're making a data set that looks exactly right, and also what your co-authors want too. You're making a data set that looks exactly right for the journal. So you have full control. It's not like the messy world of real data. As you've seen, many publications, worldwide fame, sometimes monetary rewards as well, await people who commit successful fraud and have their articles accepted, their fraudulent articles accepted in some of the world's biggest journals. And it often, again, as we've seen in this talk, can take years and sometimes decades for any detection of the fraud to happen, any punishment, any retractions of the articles. It's an extremely long process to find any fraud. I mean, those Lancet New England Journal of Medicine articles are a kind of exception in this case because they were retracted within about 2 weeks of publication. But that's the extremely unusual situation of the COVID-19 pandemic focusing people's attention on these articles, where the vast majority of scientific frauds are sitting there for years before anyone finds out about them. And sometimes, in some cases, universities and colleagues and others cover up the fraud that their researchers do because it looks, understandably, very bad for their reputation if they have a fraudulent researcher on board. So those are some reasons. We're going to hear about more reasons about the incentives of academia and so on that can push people towards finding results. I mean, psychologically, it's possible that fraudsters commit fraud because they actually believe the results. They believe themselves that those results are true, and they just want to give them a little push in the direction of being convincing. So the question is, do scientists perhaps trust each other a bit too much? It's something to think about over the rest of the day. During the Cold War, Ronald Reagan kept repeating this Russian proverb of trust but verify. And I guess my argument in this talk is that scientists do a lot of the first bit, but often forget the latter part. So I'm happy to take any questions that you have, and thanks very much for listening. Feel free to get in touch as well. But that is me done for now. So I will hand back over to Sam.
Thank you very much, Stuart. That was a wonderful talk. We're getting a lot of positive feedback from Twitter and everywhere else. Yes. I just want to exercise a bit of reproducibility and self-correction now. Roger Gina Sorola has informed me that Ioannidis did not mathematically demonstrate that most published research is untrue, despite the claim in his title. To reach that conclusion, you need to presume that most tested hypotheses have highly improbable priors. So I just wanted to clarify and avoid any confusion there. So I'm just going to take the top 2 or 3 questions in the time we have remaining. We have until about 5 past for Amy. So the top one is by Malika. She said, should retractions really be an indicator of fraud? Wouldn't this prevent honest people to correct their mistakes by fear of being judged as fraudulent if their paper gets retracted?
Absolutely, I think that's a very good question. We need to live in a world where scientists can admit their mistakes. We need to move towards a situation where retraction is not seen as something career destroying or embarrassing or really scary to do. Retractions and also corrections in cases where the whole paper doesn't need to be retracted, but it can be, a table can be replaced or a figure can be replaced or whatever it is. So we need to move towards that situation. And so it's possibly a bit unfortunate that retraction has been so strongly associated with scientific fraud. The problem is that the very, very top scientific fraud, the very, very top numbers of retractions are all instances of misconduct or fraud of some kind. But absolutely, I think we need to differentiate that. The number of retractions is increasing over time. That's been shown in a couple of different papers, but that could be not because scientists are getting more fraudulent. It could be because editors are getting more aware of these problems, or scientists are becoming more open to admitting that they have made a mistake, that they've screwed up. Hands up, I made an error there. And it's not just that's something that scientists should do or anything, but that's actually a really praiseworthy aspect of some researchers, and they must be able to admit when they've got something wrong.
Wonderful. We have a tussle for the next few questions, and I think they have covered it. So I'm just going to try and pick one of the three that I think has not been really picked up yet. And the one I'm choosing is by Andrew Miller. He asks, is there any data on the effort, brackets, person hours, invested in investigating an alleged fraud, i.e. What is the management cost?
That's another great question. I don't know of any actual hard data on it. I know lots of anecdotes of people who have looked into fraud cases or potential fraud cases and have spent hours, days, weeks, months, sometimes years of their life, and sometimes essentially digging into the data first, but then bashing their head off a brick wall when it comes to talking to the universities that the alleged fraudsters work at, people who are just ignored by journal editors who, again, are not incentivized to retract articles because it looks bad for their journal, and so yeah, I don't know about the actual the cost, but it must be very, very high. People normally who look into fraud are not paid to look into fraud, right? They're working scientists who out of their kind of sense of duty for the scientific community, spend so much time looking into this. I mean, there's also a kind of internal motivation because it is fascinating to look at fraud. I mean, we're all interested to some degree in true crime, right? And this is as best as this is as close as you can get in science to true crime, except if you're a forensic scientist, I suppose. But the point is that it's fascinating psychologically to look into that. But I would love to see a kind of even a kind of qualitative study of how much effort people put in to investigating fraud cases. Yeah, it's a great question.
Okay, wonderful. So we did start slightly early. Amy is just on standby. Just a word to the audience. So I think Stuart has already covered most of the top-rated questions. So I guess we can just move on to Amy now. So thank you, Stuart. You can pop off now. Is that I'm see?
It is. Yeah, it is. Cheers, everyone.
Cheers. Do you have some shortbread too? Or okay.
I'm not that much of a stereotype.
Okay. Thank you so much, Stuart.
Thanks, Sam. Enjoy the rest of the day, everyone.
Thank you. Okay, so Amy, I'll hand the keys over to you. So you've got a few minutes extra time. So not slightly less pressure. So I'll hand it over to you. Thank you so much for coming today.